Alright, I'm back, and I've got a browser open with this bill of materials. And you can see how I did this was that in one column, I went through all these Mouser part numbers. I used the import tool there's a Mouser BOM import tool. It pulls in a spreadsheet and quantity and Mouser part numbers. And I added those parts where I could. Then I reviewed the result. Some things weren't available, and some things I already have on hand, and so I marked those all off. This yellow item was out of stock in Mouser. I had to get it from DigiKey. Tata is the best source for alpha pots, which match this old school footprint and are actually very high quality. Those are from Tata. And then SA Modular was the source for the actual fancy Rogan knobs that popped up there that we're going to use on this module, and that are the same as the Rogan knobs that were used in the 70s. They also did some switch cabs. They had exact standoffs. I wanted, rather than have to source a bunch of them, to get the exact sizes. So I think I'm at this point actually ready to do a little soldering, and to kind of start that process. What I'm gonna do, go up here, check out the BOM. I'm looking at the part number that's up there on the screen. I have here the Mouser package, little packet that has the diodes that we're going to use. And I know that I need 4 of them. And so what I'm doing right now is I'm looking to find all the locations of those different diodes. And so I see 1 and 2, 3, and there's a 4th one somewhere. No. Yeah, D1, D2, D3, and D4. Okay. I'm gonna turn on my soldering iron. I do have a tool that helps me fold leads to an exact kind of straight shape. But it actually isn't even, the diode footprints are so small that this won't help you in bending leads to fit these very small footprints. I am live, and I am the one viewer of this stream. So hopefully some people see it on YouTube or not. Okay. So diodes are one of the parts where orientation matters. And so there is a line on these diodes. I don't even know if this will. Yeah, you can see. So you can see there on the left-hand side of the screen, I think, there's a line for that diode. And then here on the footprint, if you were to look at this, you can see that these two have a little line where that thing's supposed to go that indicate the orientation of it. So kind of see how big this is to fold the leads. if you want to be like super obsessive about it, you can make sure that the marking on the diode that indicates the part number, it says here literally 457, that is facing the viewer of the board. Actually, you know, one thing I do want to do before we do anything else is take a picture so that I have a, I know where all the reference designators are. Sometimes manufacturers don't supply this, and so you just kind of have to, it becomes very difficult to debug stuff after everything is in place because you don't know where it is. And the schematic for this is basically going to be the Buchla 257 schematic. So I think, other than whatever minor changes, it's like near identical. So here's D1. Here's D2. Fold this a little closer. Pull these legs in. This one's a little wide. I'm just gonna really click into its little exactly top one. Might redo this one. Totally unnecessary to be this obsessive about the placement of the parts, especially if you're building like a cheaper kit. You know, I wouldn't get super obsessive about it. I think one of the joys that I get nowadays from doing DIY synths is like seeing something that's like very like immaculately organized and, you know, all the resistors lined up, whatever. But that does not have to be everyone's thing, and you might think that's a waste of time. It's just perhaps the case, but cool. Okay, so looking at this board, I don't see anything else that is at this height. So what I'm gonna do at this point is grab some painting tape, tape everything down, and then start soldering. can't find the blue painter's tape at the moment, but I do have this masking tape. So what I'm gonna do is take these components down because the leads are pointing straight down. And the reason that I want to solder them like that, and I used to fold leads out and they'll stay in their place. You can flip the board over, you can solder it. It's when you want to go back and redo stuff, repair stuff, that having the leads folded out becomes like really challenging to work with. And I mean, just imagine having the pads, the place where you're inserting lead, having those both hot and with something, the friction of a lead running across it, it's very easy to pull out that piece of metal that is the pad. I mean, the pad is just like epoxied onto this fiberglass board, right? So being really diligent at this point kind of sets you up later to have something that you can more easily repair. And I mean, I don't think it's like, I don't know that much about welding, but welding seems permanent, more or less, whereas with soldering, I had another project that I'm working on where I had used components that are like lesser quality than the components that I want to use. It's a frequency shifter. It's like very dependent on the accuracy of the components. And using a desoldering gun, which I have here on the desk, I was able to pull out all those components. And so basically back to, only 50% of the parts are laid down now, and I can just go back and put on whatever I want. So this solder, here, I'm going to open some windows. Get some airflow. This solder, I believe, is 60-40 lead tin. And so most modern electronics manufacturers in the United States use lead-free solder. And when you see the acronym ROHS, which is like, that refers to like the environmental standards, such that we don't use lead-free solder anymore. And so the thing about lead-free solder is that it has a higher melting point, so it actually becomes harder to work with. And so solder with lead in it for doing work by hand does really help. This also has water soluble flux in it, so there are a lot of solder types that are no clean. And so this solder, you can just solder, and the residue that's left over that looks like flux, and it looks like kind of this like caked, it's like like a brownish kind of like translucent layer. That's fine. It's non-conductive. It's not detrimental to the board at all. Whereas water soluble flux can be conductive. I believe it can be detrimental to the board, but it's water soluble. So I'm going to use demineralized water and clean off all the flux, which circuit boards can go in water. The problem is the minerals and like whatever else is in the water. And so using demineralized water, clean it, it'll look really clean, and there's no flux residue left over. Obviously, I'm gonna wash my hands after I do this, so I don't like touch anything and then eat that thing. So I'm gonna do is one leg of each of these. And kind of holding it long enough for this solder to like clearly travel into the space inside the pad, right? And so I've only done one hole, but now that we've done that one hole, they will stick to the board. Oh, this one needs. So I soldered these. I thought these were. I soldered one vertically. This guy's still loose. Okay, gonna flip the board. Okay. So now they're like half placed, and that lets us. Should they be like sticking out or anything? This is a good point in the process to catch it. So I'm gonna finish soldering these leads. The cat is meowing. Purcell, what do you want? Cool. And now to cut the leads. Great. So the first parts are soldered onto this board, which is great. Super exciting. Okay. Now I'm gonna go over this bomb. I'm gonna have Nick call him and just go check it, and just remind myself that I've installed those components. Okay, and so now the bomb is organized in increasing values of resistance. And so we're going to start at the lowest one. I will find that. I'll use the lead bendy tool, bend the leads, put it in the slot, and I'm going to try to do maybe half, maybe all of the resistors, and then tape them all down and then solder them. So I mentioned earlier the difference between there's like the 1% metal film resistors and the 5% carbon film resistors. I think this is because the manipulation of voltage is so sensitive, like at least because of how we perceive pitch and how the voltage is related to pitch, and we can perceive when something is a few semitones off, and even like fractions of semitone, whatever, and so you want the voltage to just be like as accurate as possible. I don't think we're going to be able to like do like perfect nailed 3-part harmony where like every oscillator is hitting like the exact right pitch, but also like not the intent with this system. I got the definition for semitones wrong. We can perceive like a semitone is a half step, so C to C sharp. We can perceive like quarter, an eighth step. It immediately sounds dissonant to us. Okay. The rest of these diodes, I am going to put, well, I have a new sorting system for all my parts that I'm gonna put this into. Okay, but first I want to get, these are really fun. I don't think we're using these in this project, but they're huge. Oh. So yeah, the boxes, help. They're just like so many resistors. Even this, like, it would be great if it were all sorted and in the same increasing order. It would save some time. I might do that at some point. It's hard to find like the exact right size boxes that you need all the time. And there are also way more values here than we're going to need for the 257. Oh wait, this is going to be Here's a schematic I have on my desk from debugging the mixer and spring reverb of my TTSH, which is a clone of an ARP 2600. Stop. I've already found the cap again. Okay, 1% resistors. I am looking for 680 ohms, not 680 kilo ohms. I might try to do some like simple sorting as I put this back in. All right, 680 ohms. Oh, for now, I'll not do that. And I am just checking if the Buchla 259 is going to use these resistors, or whether once I pull these three, I can sort it and just put it in a little box. So these are actually really resistant to changing their value in relation to like changes in temperature. I could not explain to you parts per million how that measurement works. That's my understanding of it. So lower is better. Whereas something what's called a hey. Everybody thinks that's a toy. Not a toy, it's my box of parts, it's a bag of parts. A Tempco resistor, or I think thermistor, like there are a bunch of different names for them, are often used. God, you gotta stop. She loves these bags. You might have something like 3,300 parts per million or 3,500 parts per million, because you want the value to change in relation to temperature, so that as part of this exponential conversion circuit that's determining the pitch relative to voltage, which is like the most sensitive part of like the pitch calculation. I mean, it is like the pitch calculation process, and you want that to be as like the relationship to be as constant as possible, and that resistor allows you to compensate for that. This process is not perfect, And this is why synthesizers take time to warm up, like literally warm up, as the circuit kind of like reaches the temperature that it's going to be for the rest of the session. You know, and if the resistor were perfectly compensating for temperature, there would be no need to warm up. All right. So I'm verifying the values in this by looking at the little stripes. This is gonna be hard. All right, I think I got this blue. You can see this blue color. I think this is green. I'm gonna calculator. So if you don't know and you haven't memorized all of them yet, as I haven't, DigiKey has a great resistor code calculator. And so I think this is blue. Yeah, I described this as gray, and then black, brown. So 680 ohms. No. 680 ohms, 1%. It's a good idea to verify these. I mean, I highly doubt that Master would have made a mistake, but when you start debugging circuits and you have to like verify every resistor value against that picture that we took earlier, and like you'll notice that these say like R56, meaning that you've got to look up R56, see what the value is, and then verify what it is against the board. You can save yourself those kinds of problems by proactively checking values as you go. Just at the very least, I always get the multiplier wrong, and the 680 ohms. The multiplier is the fourth band on a 5-band resistor code. So black is times 1, so this is 680 ohms. And then if it were brown, it's times 10, and red, it's 68K, and so on. I haven't memorized all of those yet, but I hope to fairly soon, so that I don't ever have to look at the monitor to do this. Okay. So I'm gonna go back over here, and now R19, and I also tried to put the color codes in the same direction as the screen print. So it reads R19 from left to right, and so I have blue gray. So this is like a little. I want smaller than this. Let's see. That was when I pull it through. It's like a little wide if I use this setting. Yeah, that looks good. I might see if folding it with the hand pliers gives me a better result, but that looks pretty clean and in there. R56, this is 2 identical circuits, so it's really easy. So R19 is up here, R54 is in the same location, just on the other half. And there are other, there are modules, plenty of modules like this that exist in all the formats. Buchla 258, the dual oscillator, also just like 2 separate circuits. The Polymoog resonator that I built recently. The 3 circuits that varied only by like specific values that determined what the filter values were. All right, that feels way better. Let's look really clean the environment. Redo this. And yeah, I think along, maybe a year ago, I would have been more like in a rush to like get it done. And I think part of it now is just that, finding it. It's kind of knitting or something. It's just the activity itself is really calming. There's R92. 175. Already scrubbed something. I gotta go figure out what it is. I would love to find R91 before I do it. Where are you hiding? Should I check the other side of the board just to make sure, especially for one that's so that looks like it might be like the last numbered resistor. I guess this is R92. Among the last numbered resistors, sometimes you'll find parts on the other side, especially on surface mount builds. Okay, got 90, 91. This process starts to go a lot faster as you start putting all these resistors in, because like right now the part that takes the longest is finding all these different numbers on the board. So great. Okay, so what I'm gonna do at this point, so you guys get some plastic bags, and kind of I discovered a new sorting method. So what I've been doing is using 3x5 bags to put components in so they fit in the same size as an index card. So then anything that you would use for an index card, in that, so like plastic index card dividers or cardboard dividers or any of those containers, you can use those. But all I have right now are 5x5 boxes, 5x5x5, so they're like a little tall. So what I'm gonna do right now, let's take this. It might be like a little less static protection here, but I'm not hyper worried about it. Here's the 3x5 bag. Pour that in. Great. Okay. And I have scissors here. And so I'm cutting off this section that has the description of what it is in the part number. And I'm going to put that over the top of the bag. I mean, in part to give it some structure. And then as you're going through it and looking through it over the top, you can identify what it is. And this seems like a lot of work right now. But again, like long term, that saves you time. Just like if you can go through a build and do most of it from parts you have on hand, it saves you so much time like sourcing components, and it saves you money building them. So we have just started this process really. So I don't know. For right now, I'm gonna put all the parts in these boxes. And I'm gonna do the same thing here with resistors. Yeah, the minimum order quantity for these Chicon resistors is 200. So I think it got extremely cheap at that point. I think 200 costs like $4 or something. But yeah, you got a lot. I need more masking tape. Packaging tape. Resistors, I really want to get the value over the top of the fold, just so I can see it from the top when I'm going through all of it. I'm going to turn my auto gain, whatever, on the microphone. Funnily enough, I so rarely record myself speaking or record things that aren't from synthesizers. I don't have like a mic setup. This might be better. This. I should just get a fucking directional mic. That's what I should get. I don't even think they're that expensive. Okay. So, for now, I'm just gonna check and check for these 3 resistor values because we placed them. Even though we haven't soldered them yet, I guess we're gonna solder all the resistors at once. kiloohms is next. Starting with R33. Yeah, so looking at this, brown, black, black, brown, brown, 1, 0, 0 times 10 at a 1%. Okay. This is R33. Parcel is bringing me a mousey. What's up, buddy? Yeah, give me that mouse. Parcel has brought me a gift, which is an auspicious sign. Want to say hi? No, there we go. It's my cat. One of them. Just hanging out. Yeah. Right. There's one. Our 43 is next, which is right next to it. That's good. I do wonder, well, whether splicing the parts of this where there's the actual talking could be helpful. Hey, no more. I'm gonna put out a toy for them. Excuse me. R71, R81 is. Oh, I wanted to go the other way. I've done all of these backwards. Again, just like a neurotic detail. Just doing them in this direction. I mean, not that important, but I mean, why not? It's COVID. We got time. Wait, turn my software on. Great. All right, check this off. You guys are gonna be hearing Purdy play with this toy. Come here. Come here. I've been using snapping to try to, whenever the cats eat, to get them, there's like to train them to come to me when I snap. But now whenever I casually snap, Percival thinks I'm gonna feed him more food, which is not the case. He has the propensity to become a big boy. Dude loves to eat. All right. 1.5K. I feel like I saw that. 7. Pull this back up. All right, so R40 and R77. So yeah, now the setup very much on our way to building this module. It's like when you're in the road trip and you leave the city boundaries or whatever. So 1.5 is brown, green, black. K is brown, and brown is 1%. So I'm not using this right now. I feel like I might try to find one of these folding tools that's even smaller and has like smaller footprints. 40. And R77. Hold that a little closer. And by not soldering these now, what sometimes happens when you're going through these and you make a mistake is that you'll find some designator where you've already filled it in with another resistor. And for me, usually I can look back and I've like swapped 3.3K and 33K. If they're not all soldered in yet, you don't have to go through the process of removing it, which is just was very unpleasant until I got my desoldering gun. But best to avoid, for sure. It's messy. All right, 3.3K. Yeah, again, you know, one thing that I used to do and might still do for some projects is you can order the exact number of parts that you need, and when Monster delivers them to you, you know that when you've gone through the bag and you've like placed all the components, it's really easy to keep track of everything. But you're paying like a premium to do that. Yeah, some parts have delivery minimums, but I find it nice for like some of the surface mount builds where the part it's cheap for them to cut it to cut the tape, and it helps you. The parts are so small, like helps you keep track of everything, rather than like a jeweler's. A series of small boxes. It's like a jeweler's organizing tool. Let's see. All right, here we go. This entire bag of 200 resistors so that I can place one of them. This is an obsessive detail. I just love this this orange that you get on resistor. It's so vibrant. My nails are a little dirty. I didn't expect it to catch literally all those details. So I will. This is R6. All right, I think now that I am well on my way here, I am gonna sign off of Twitch and watch some Star Trek while I do this. Delightful. And then maybe pick up streaming again when I think when I place all the components inside of the meltdown and maybe show you guys the before and after, what it looks like when you watch the board. Just like pretty satisfying. All right, close OBS.